Hi guys, we're going to jump right into the next lesson, which is 2.2. So let me share my screen with you. Get to the top of our notes. Okay, so we have some vocabulary to go through. Today we're going to be looking at quadratic equations, quadratic functions written in standard form and intercept form. All right, this is a 2-day lesson, so I'm only going to do the odd problems. I'm going to do like every other problem today, and then I'll finish up the lesson tomorrow doing the other problems, okay? So I'm going to be talking about the axis of symmetry during class today. The axis of symmetry, definitions there for you, is a line that divides a parabola into mirror images and passes through the vertex. You're going to see that I use the abbreviation AOS to abbreviate the axis of symmetry. All right, standard form of a function, okay, is written in the form ax squared plus bx plus c. You guys actually worked with this a lot in Algebra 1 because we factored standard form functions, okay? Minimum value, when our parabola opens up like a U, the parabola has a minimum. The function has a minimum, and it's going to be the very bottom of the parabola, and that's where the vertex is, and it's the y-coordinate of the vertex. All right, the maximum, if our parabola is flipped upside down, okay, if it looks like a hill, then the very tippy top of the parabola is the maximum, and again, it's the y-coordinate of the vertex. Intercept form, we have intercept form, which is really helpful to graph if we want to plot the x-intercepts and then go from there. So a quadratic function written in intercept form is a times the quantity x minus p times the quantity x minus q. All right. So the next bit of information, just like I said in the first set of notes for this chapter, this is all really important information, but if I just read it to you, you're not going to really understand it until we go through the problems. So I would encourage you to come back and read through this information after we've worked through some problems, because it will hopefully make sense to you. Okay, but it's a lot of notation, a lot of little things that, again, won't really make sense and will just kind of sound foreign until we go through the problems. All right. So let's jump right into the very first problem. Okay, so we are asked to graph, label the vertex, the axis of symmetry, find the min or max value of the function, describe the domain and range of the function, and then explain where it increases and decreases. So we have a lot of work to do for each problem. All right. This function is actually written in our vertex form that we worked with in our last lesson. So let's look at it in vertex form. Okay, and I'll kind of review that as we do it. So our function in, ignore that. Our function in vertex form, try this again, is f of x equals a times the quantity x minus h squared plus k, right? That's vertex form. And the function that they give us is f of x equals x plus 1 squared. Okay, so we should be able to list the values of a, h, and k like we did in the last lesson. Here, a is just 1, so that means that it didn't flip upside down, it didn't stretch or shrink. H is going to be a -1, which means it's going to move left 1 unit. Okay, and then k is equal to a 0, so it means it didn't move up or down. So I can graph quickly, thinking about vertex form. Remember what we did in the last lesson. My parent function, the origin's here, but I'm going to move it over 1, or sorry, the vertex is there. I'm going to move it over 1 unit to the left, plot my point, and then follow that pattern because there's no stretch or shrink. So that means it's out 1, up 1, out 1, up 1, out 2, up 4, out 2, up 4. And then I draw my parabola. Right. Now from there, you're asked to identify the vertex. Well, the vertex, remember, is h comma k. We can also look at the grid. The vertex is -1, 0. We're asked to identify if it has a max or a min. Because there's a bottom, right, a very low point, that means there's a min. And the minimum value, the lowest y value, is 0, right? And it's related to the vertex value. So the minimum is 0. There's no maximum because if there's a min, there's no max, okay? Next thing is the axis of symmetry, AOS. The axis of symmetry is a line that goes through the vertex and divides the parabola into mirror images of itself. I'm trying to get a different color. There we go. So I could draw this vertical line right here. This would be your axis of symmetry. It's a line, so there's an equation that represents that line. The axis of symmetry is x is equal to -1. All vertical lines have an equation of x is equal to some number. And since it's going through -1 on the x-axis, the equation of that line is x is equal to -1. Okay? We're asked to explain the domain, the range, and then increasing and decreasing. All right, so domain. When we talk about the domain, we're referring to the x values. And there's two things I like to do. I like to look at the function itself and then also the graph. When you look at the function itself, ask yourself, would I be able to plug in a negative value here, a positive value here, a 0, a decimal, a fraction, and calculate it? You could. There's no restrictions on what numbers you can plug in for x. So that means it's all real numbers. Also, the graph itself is going to go through every single x value, positive and negative, okay, associated with our coordinate grid. So that's also why it's all real numbers. The range, talking about the y values this time, and this time I like to look at just the graph, okay? Since the parabola is in the second quadrant, it's also in the first quadrant, and it goes up, up, up on both ends forever and ever, but it's never going to be in this quadrant or down here, right? That means that the lowest y value, as we said, the min is 0, the lowest y value is 0. We're never going to have any y values that are negative because it's not going to be down here. So my range is y is greater than or equal to 0. All right, the last two things, increasing and decreasing. If you were to trace this parabola, right, if you were to draw a U, it's a U shape. When you write a U in English, you go from the left side to the right side. I want you to say to yourself as you trace, down, 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 change direction, up, 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 up. Okay, again, you're going down, 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 and then you change direction because now you're going to go up, 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 up. So up means you're increasing. You're increasing on that side of the yellow line, and you're decreasing over here, going down, 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 okay? So it's all related to that yellow line, the axis of symmetry. We say we're increasing to the right of AOS, of the axis of symmetry, right, to the yellow line. And you're decreasing to the left of the axis of symmetry. All right. All right, guys, let me get us started on the next problem. Trash. And then mouse, and we scroll down. We're skipping 2. We'll come back to that one tomorrow. Moving on to 3. So 3 is in standard form, okay? So let me get my pen. Good. So standard form, I'll write it up here since this is the first time we're graphing from this form. F of x equals ax squared plus bx plus c, okay? And the function we're given is 3 halves x squared minus 3x minus 1. First thing you want to do in standard form is take note of the a, b, c values. The a value is 3 halves. The b value is -3. The c value is -1. Okay? The a value tells you the same thing in this function as it did in our other function form, in our vertex form. The a function of 3 halves, or if you want to translate that to 1.5, means that there's a vertical shrink, or excuse me, vertical stretch of 3 halves, or 1.5 units. It also means it's opening up because it's positive. okay? The C value, that's actually going to be our y-intercept, and I'll explain that more when we actually graph. But what you need to know is the B value, because to get these problems started, the first thing you need to calculate is the axis of symmetry, and we use this little equation, x is equal to negative b over 2a. So I'm going to plug my values in, negative, and then b is negative 3. Kind of ugly, but we'll clean up the signs in a minute. And then 2 times the a value, which is 3/2. Don't get panicky because there's a fraction. Negative, negative turns into a positive. 2 times 3/2, well, you can multiply 2 and 3 together and get a 6, and then 6 divided by 2 is 3. Or you could cross cancel, right? Cross cancel the 2's before you multiply, and you're just left with 3. You're left with 3 over 3, which is equal to 1. See, I told you not to panic. All right, so your axis of symmetry is x is equal to 1. I'm going to reset just because I need room. All right, so okay. That's my pen. Kind of erase this, so I'll rewrite the 2. All right, next thing we're going to talk about is the vertex. Well, remember the axis of symmetry goes through the vertex, and the axis of symmetry has the same x value as the vertex. So right now I know my x value is 1, but I need to find the corresponding y value. If you know the x value of a function, how can you find its corresponding y value? You plug it in, okay? So you're going to take this function and you're going to plug in 1 to figure out what the y is equal to, because you're going to replace f of x with a y. So let me write that. Y is equal to 3/2 x squared minus 3x minus 1. Substitute in a 1, so 3/2 times 1 squared minus 3 times 1 minus 1. So I have 3/2 times 1 minus 3 minus 1. 3/2 minus 3 minus 1. You can change this to 1.5 and then subtract 3. You get common denominators. It's kind of up to you. You'll probably just use your calculator, I'm guessing. But if I want a denominator of 2, right, you have to multiply top and bottom, make these all ones, top and bottom by 2, so that's 6/2. Multiply top and bottom, so 2 over 2. So 3 minus 6 is negative 3/2 minus 2 over 2. Same change leaves me with negative 5/2. Okay, so my corresponding y value is negative 5 over 2. Now, when I go to graph, I'll probably change that into a mixed number because it's going to be easier to graph in a mixed number form. Let me erase all this. I'm going to even clean that up too. It was 5/2. Let me fix that. Negative 5/2, right? Negative 5 over 2. Okay, so let's go ahead and graph the vertex. The vertex is at positive 1 to go over 1 unit, and then down negative 5/2, which is the same thing as negative 2.5. So my vertex, let's see if I can get it in the right spot, is right here, sort of. Okay. All right, and then we can use that vertical stretch or shrink to do the pattern, right? So the pattern is usually out 1, up 1. We have to be careful because remember where we're sitting. Out 1, up 1, and then it would be out 2, up 4. But our up movements have to be multiplied by 3/2. All right, so that's a little tricky. The other thing you can do is graph using the y-intercept. So since this value is your y-intercept, we can plot a point at -1 on the y-axis, right here. Okay, now we also should, and I can do that now, I can graph the axis of symmetry. Remember, the axis of symmetry is a line that goes through the vertex and cuts the parabola into a mirror image of itself. The reason I'm pointing that out now is because you can flip that other point, the y-intercept, you can flip it over the over the axis of symmetry, right? Flip it over and get another point. And as long as you have 3 points, you can draw your parabola. So sometimes the y-intercept is helpful for graphing in this form. Other times, like if they give you a really big number as the y-intercept, then it won't help you, okay? But that's one way of graphing kind of quickly. So we have the axis symmetry, we have the vertex. We still have to figure out max or min. Is there a minimum or a maximum? There is a minimum. The minimum is the y value of the vertex. So the minimum is 5 halves. That is the lowest y value. Domain and range. Domain. This graph is going to go through, correspond with every single x value, positives, negatives, 0. So the domain is all real numbers. The range related again to the minimum. The range, this is the lowest y value we keep saying. So if that's the lowest y value, that means that all the y values have to be greater than or equal to that lowest one, which is negative 5 halves. Last thing we have to do is increasing and decreasing. So we're increasing, right? If we say down, 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 up, 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 up. So we're increasing to the right of the axis of symmetry. So increasing to the right of AOS. And remember over here again, when you trace, you say down, 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 down. And that's on the left-hand side of the axis of symmetry. So decreasing to the left of AOS. Okay, so that's one in standard form. Let's get set up for another one. Okay, so in exercises 4 and 5, we're going to graph the function, label the x-intercepts, vertex, and axis of symmetry. So I'm going to, again, just stick with doing the odds. Actually, for this one, I'll stick with doing the odds because I don't want to forget tomorrow what I'm supposed to do. All right, so first thing I'm going to do is write down the intercept form of a function, which is of a quadratic. F of x equals a times the quantity x minus p times the quantity x minus q. And this function is negative 7x times the quantity x minus 6. Right, that's the function that's given. So, equals. All right, so we're going to identify our a, p, and q values. The a value is a negative 7. I kind of made the equal sign and the negative turn into 1, but you can see over here it's a negative 7. Okay. The p value, what number was plugged in for p? A positive 6. And the q value, well, there is none. So you could write it if you want as x minus 0. That holds no value. Okay. The q value is a 0. So the a value does tell us whether or not the graph opens up or down, vertical stretch or shrink. So I know that this graph is opening down and there is a vertical stretch by a factor of 7, okay? I also know that my x-intercepts, that's what p and q are. These are my x-intercepts. So if those are my x-intercepts, I can plot a point at 0 on the x-axis. That's right here. And I can plot a point at positive 6. 1, 2, 3, 4, 5. I'm going to be off the grid. 6. Okay. Now, I need at least 3 points to draw my parabola. The one point that I'm missing is my vertex. Think about the fact that if those are the x-intercepts and your parabola is symmetrical, wouldn't the vertex have to be somewhere in the middle? Right? So we're going to take the average of the x's, and when you do that, you're going to have an idea of where the vertex is located. So I'm going to say average intercepts to find AOS. So if you take the intercepts, 6 plus 0, and you average them, meaning add and divide by 2, right? If you average 2 test grades, you add and divide by 2. You have 6 over 2, which equals 3. So we just determined that your axis of symmetry is x is equal to 3. So I'm going to change my color to yellow. I'm going to go to where x is equal to 3. 1, 2, 3. That's right in the middle, right, of those two x-intercepts. And I'm going to draw my axis of symmetry line. Okay, so I know that my vertex lies somewhere on that line because the axis of symmetry goes through the vertex. Okay, so right now I know one thing. I know that my vertex has an x value of 3. I don't know my y value. And how do you find a y value of a function if you're given an x? You plug it in. Okay, so let me clean up just a little bit some of the stuff that I can afford to get rid of. So we'll get rid of this. So axis of symmetry is 3. Okay, I'll rewrite that. All right, so let's go back up here. So your axis of symmetry is x is equal to 3, and your vertex is 3 comma something. So to figure that out, I'm going to take the original function. Actually, I'll probably look over here so I don't get confused by the extras that I wrote, and plug in 3 everywhere you see an x. So it's y is equal to -7 times 3, and then 3 minus 6. Make sure you follow order of operation. You can do your multiplication. That's fine. -21. And do your subtraction, -3. And then finally do your multiplication. Negative times a negative is a positive, and that's going to be 63. So that's really, really high, right? I have to go all the way up to 63. So I'm going to have to obviously change my scale on my y-axis. It's going to be distorted, my parabola, since I didn't change my x-axis scale, but I'm changing my y-axis. So if you check this in your graphing calculator, it's not going to look the same. But I'm going to count by 20. So I'm going to say that this is 20. This is 40, this is 60, 80. So if I have to plot a point, the vertex is at +3. So 1, 2, 3, and then up 63. I'm going to just approximate it about right there. Okay. And then I'll draw my parabola. All right. So we have the x-intercepts, we have the vertex, we have the axis of symmetry. Okay. And let me see, where am I? Oh, that's not what I wanted to do. I think I'm going to save the word problem for tomorrow. Let me just check something before I say goodbye. Yeah, we will save the word problem. We'll save that for tomorrow. Okay, guys? So, oh, I keep using the wrong thing to try to get out of here. All right, guys, so that is the end of that lesson, and we'll finish it up tomorrow. All right, have a good night. Bye.